Hi, I'm Kalaimathy Gunalan from RY41. Now I'm going to present my answers that I got from Lab 3 operational amplifier for two different circuits which are comparator and summing amplifier. So we're going to see two different type of comparator first. One is zero level detector and another one is non-zero level detector. So for the first circuit, zero level detector, this is the circuit I did uh, in multisim live. So here we can see the input value is in green color signal and the output value is in blue color waveform. So the reading is over here. For the green color, the input is approximately 10 volt and for the output is 13 volt. So for the second comparator, non-zero level detector, so these are the calculation. The formula that we use is R2 divided by R1 plus R2 times with V in. So for this circuit I have used V in as 15 volt, so I've used here 15 volt. So for the first resistor value, which is 4.7k and 1k ohm, the voltage reference is 2.63 volt, and the second resistor value, which is 1k and 2k ohm, the voltage reference is 5 volt, and the third value of the third resistor value, which is 1k and 1k ohm, the voltage reference is 7.5 volt. So these are the calculated value and these are the values that we get from the measurement. So it's almost same. We can see here the second value is 5 volt and here is 4.9999, which is almost same with the calculated value, and here also the same situation goes on. And for the measured reference voltage, now we're going to see the circuit. Okay, these are the resistor values that we have changed earlier. For different circuit we have used different resistor value. So and the here are the waveform for input and output. The green color is input and blue color is voltage reference waveform. So I have done three different circuits for this part, and the answers is already have been discussed. And for the last part, summing amplifier, there are two different circuit with two different values, resistor values. Okay, for the first set of resistor, all the resistors are 10k ohm, and the calculation, we use the formula RF divided by R1 times with V1 plus RF divided by R2 times with V2, and inside the and plus both answers, and the answer will be negative. So here we can see I have solved the calculation using the value resistor value which is already stated here, 10k 10k 10k, here also 10k 10k, and the input is 1 volt, and from the calculation we get negative 2 volt. And from the experiment, which from here, from the circuit, we got 1.9942 volt, which is almost same with the calculated value. And for the second part, we have different resistor value. RF and R1 is equals to 10k and R2 is 2k. So for the calculation, we have used the same formula and get the answer negative 6 volt. And for the experimental, which is measured value from the circuit, so we got 5.9628 volt, which is almost same with the calculated value. And the input value over here is 1 volt. So now we're gonna discuss the questions. The first question is, what do you understand about summing amplifier? Summing amplifier is a combination of the voltage present on two or more input into a single output voltage, which is it will combine two input into one output. And then what the second question is, what happened to the output if the frequency of the sources is increased to 3k hertz? Briefly explain. So there is no changes in amplitude of the output, it will remain same, which the V peak to peak will be remain same, and the period of an waveform decrease because the frequency and period of waveform has an inverse relationship. For the discussion from part A and B, a zero detector is a comparator with a reference value set at 0. It is used for detecting the zero crossing of AC signals. For the non-zero level detector is a circuit that can detect when an input voltage is bigger or smaller than the given reference voltage. Is called as a non-zero crossing detector. Other than that, in terms of calculation, there are different formulas for both circuits. For the discussion part C, which is summing amplifier has multiple input that applied to the inverting input terminal of the operational amplifier, while the non-inverting input terminal is connected to the ground. Due to this configuration, the resulting output will be of the sum of all the input voltage applied but inverted, and this is the reason to add negative in the formula of V out. For the summing amplifier, from here we can see there is always a negative in front, so it's because the signal is inverted. So we can see here clearly the input signal is inverted from the output signal. That's the reason why there is a negative. And for the conclusion, as a conclusion of this lab, I have learned to demonstrate and investigate a comparator circuit. Besides, I have also learned to demonstrate and investigate a summing amplifier circuit. That's all from me for this discussion for lab 3, and thank you.